Assalamu alaikum. I'm Mark from BSPT and my presentation topic is ruthenium. These are the contents of my presentation: introduction to ruthenium, structure of ruthenium, physical properties, chemical properties, extraction, applications, and bonding. First, have a look what ruthenium is. Ruthenium is a chemical element with the symbol Ru with atomic number 44. It's a transition metal, block D element. It belongs to the group 8b of the periodic table and period 5. Ruthenium is one of the rare metals in the Earth's crust, which means that it is not easily available. The red circle shows the position of ruthenium in the periodic table. It belongs to group 8b of the periodic table, which is one of the transition metal groups. So ruthenium is transition metal. This is the structure of ruthenium. Electronic configuration is given here. Total number of electrons in ruthenium are 44, protons 44, neutrons 57, atomic weight 101.07 amu, atomic radius 146 picometer. So there are total 44 protons and 57 neutrons in the nucleus. As you can see in the diagram, nucleus is in the center and around the nucleus are the shells in which there are 44 electrons. Electrons are shown by blue color, neutrons by yellow, and protons by red color. Now have a look at the crystal structure of ruthenium. So ruthenium exists as solid at room temperature. Its crystal structure is hexagonal closed pack structure. It is one of the most stable structures and has highest packing density. As you can see, this is the hexagonal closed pack crystal structure of ruthenium, which is a regular structure. Now have a look at physical properties of ruthenium. So ruthenium is hard, lustrous, grayish white solid. It is hard, it means that it has firm and clear shape. It is lustrous, it means that its surface is shiny. It is malleable, it means that it can be shaped in different forms. It has high density of 12.2 grams cm cube. It has high melting point of 2334 degrees Celsius and boiling point 4150 degrees Celsius. It is a good conductor of heat and electricity, as we know that it is transition metal. So it's a good conductor of heat and as well as electricity. Chemical properties. So ruthenium does not react actively with most chemicals because it is non-reactive. It does not oxidize at room temperature because it is resistant to air. It does not even react with acids as it is extremely non-reactive. It can lose and gain electrons to form cations and anions respectively. Most common oxidation states are +2, +3, and +4. Most stable oxidation state is +8. Ruthenium forms basic oxides at high temperatures because at low temperatures it is non-reactive. So in order to form oxides, it must be given high temperature. Now let's see how ruthenium is extracted. So ruthenium is one of the most rare metals in the Earth's crust, as we have discussed earlier that it's not easily available, and it is about 0.004 parts per million of Earth's crust, which is a very little amount. Ruthenium is obtained by separating it from other platinum metals such as platinum, palladium, and osmium with which it occurs. As we know that it belongs to platinum group of periodic table and it is related to platinum. These metals are usually obtained as byproducts during the refining of nickel metal. They are then separated from each other by a series of chemical reactions. Now let's check the applications of ruthenium in different fields. So ruthenium is used in jewelry because of resistance to air to prevent corrosion. It is used as hardener for palladium and platinum for wear resistance. It is used in computer hard disks to increase density at which data is stored. It is used to coat surface of electrical terminals and to prevent them from being oxidized as worn out. As we have studied, we have discussed that ruthenium is non-reactive to oxygen at low temperatures or even at room temperature. So that is why we use it in electrical terminals to prevent them from being oxidized. It is used in solar cells as well, which convert light energy into electrical energy. It is used as a catalyst for ammonia and acetic acid production. It is used in pen nibs to harden and strengthen them and to increase resistance against corrosion. As we know, ruthenium is hard and resistant to react, as it is really non-reactive. That's why we use it in pen nibs to prevent them from corrosion. Bonding. So ruthenium reacts with halogens to produce halides at high temperatures. They cannot react in low temperatures, as we have discussed earlier, because they are highly non-reactive. That's why we have to provide them high temperatures to react. The highest known ruthenium halide is hexafluoride, a dark brown solid that melts at 54 degrees Celsius. It hydrolyzes violently upon contact with water and easily disproportionates to form a mixture of lower ruthenium fluorides, releasing fluorine gas. Ruthenium forms different oxides. The most common of them is ruthenium 4 oxide. It is an inorganic compound with the formula RuO2. Bonding. Ruthenium ligand bonds. The types of the ruthenium ligand bonds of our interest are ruthenium carbon, nitrogen, oxygen, phosphorus, sulfur, chlorine, and hydrogen bonds, which are common to many of the synthesized ruthenium complexes for various applications. Ruthenium forms a wide range compounds with carbon ruthenium bonds, for example, rutheniocene. Ruthenium forms a variety of coordination complexes. Examples are many pentaamine derivatives that often exist for both ruthenium 2 and ruthenium 3. That's all from my side. Thank you so much. Allah Hafiz.